Well, this is what I'm going to do in this talk. With a few words of introduction, talk about the claim that extraterrestrials are here, and then look at some arguments. The argument from colonization, calculating the numbers of extraterrestrial civilizations that we might expect to see, the program for the search for extraterrestrial intelligence, and then finally, what if? A little theological reflection about extraterrestrials. Now, this is a quote from Giordano Bruno. There are numberless Earths circling around their suns. No reasonable mind can assume that heavenly bodies, which may be far more magnificent than ours, would not bear upon them creatures similar or even superior to those upon our human Earth. So this has been thought about for centuries. It is not a new idea. In the film Contact, we have Jodie Foster says, "I've been searching for some reason why we're here, who we are, what we're doing here. It's worth one human life." Well, the interest in extraterrestrial life, especially, of course, extraterrestrial intelligence, is enormous if one is to judge by the proliferation of films, TV series, and books on the subject, and by the claims of sightings of alien spacecraft and aliens themselves, and even more astonishing of claims made by many to have been abducted by aliens. And this widespread interest is not confined to the general public. There is considerable interest in the subject in the scientific community. The subject might even lay claim to a degree of respectability these days. And as proof of this, one might cite numerous books and papers by professional scientists, and of course, most especially, one can point to the SETI Search for Extraterrestrial Intelligence program, in which massive effort by the world's most powerful radio telescopes is devoted to just this search. Well, it's clear that behind much of this interest is a quest of a religious kind. You can see that from Jodie Foster's statement. A quest for understanding our own place in the universe. A quest for meaning in the light of our perceived loneliness in the universe. Pascal, you remember these, spoke about the vastness of the cosmos being frightening. Our need for relationship as human beings, and such a quest is evinced by this quotation. So I'm going to review the evidence for extraterrestrials and give a brief theological response. Now, it's interesting that some 57% of the US public believe that the Earth has indeed been visited by aliens, if opinion polls are to be believed. And a large number believe in alien abductions of the kind portrayed in the X-Files. So what are we to make of this claim? Well, of the many sightings of unidentified flying objects, UFOs, the vast majority end up being FOs, flying objects that have been IFOs, identified flying objects, actually. They're really sightings of Venus or of an aircraft or of a weather balloon or something of that kind. So let's just examine this in a bit more detail. We can divide, as I say, flying objects into those that are identified and those that remain unidentified, UFOs. And it is quite interesting that the pattern of reporting for each type of object is virtually the same. Time of day, duration, age, and sex breakdown of the observer are all similar. And very significantly, both identified flying objects and unidentified flying objects observers show a prior interest in unidentified flying objects orders of magnitude higher than the general populace. So people who see either have a high interest. And there is a very, very interesting statistic. Year on year, the number of FOs, the number of flying objects altogether, fluctuates enormously. But the proportion of them which remain UFOs, unidentified flying objects, does not vary with the overall level of sightings. Just think about this for a minute, on the assumption that UFOs are really aliens or alien spacecraft. As an example, in 1966, there were 3 times as many FOs as in 1963, but in each year, 3% were UFOs. The question is, why on earth should a 3-fold increase in alien activity cause people also to report Venus and weather balloons as UFOs at 3 times the previous rate? If you think about that for a minute, I think the far simpler explanation is that human beings, being fallible eyewitnesses as they are, it is not surprising that there is a small residue of objects that remain unidentified, unexplainable. I think it's a bit like the police who don't solve every crime of murder or armed robbery, but we don't ascribe the unsolved murders or bank robberies to aliens. As one author, Schaefer, says, why should we ascribe unexplained celestial phenomena to aliens? So I think this means that the argument that extraterrestrials are indeed with us is somewhat dubious. So the argument from colonization. This chap's planting his flag. Well, one of the most powerful arguments against the existence of extraterrestrial intelligence is the one which begins from the question, where are they? Indeed, even more sharply, why aren't they here? Is there no evidence that ETs, extraterrestrials, have visited the Earth in the historical or geological past? In particular, it is certain that the Earth has never been taken over by an ET civilization, since this would have put an end to our own civilization. And there are 4 possible ways, I think, of reconciling this lack of evidence with the view that ETs are common in the galaxy. Well, maybe interstellar space travel is impossible, so they exist, but they couldn't have got here even if they wanted to. Maybe space travel is possible, but they don't travel. They don't bother. Or perhaps they destroy themselves before they've got to the stage of developing space travel. Maybe they are exploring the galaxy but haven't got here yet. Or maybe they've actually reached the vicinity of Earth, but they have maybe some ethical reason for not interfering with us. They're very benign. Well, now, let's look at these. Interstellar space travel. Well, space scientists, I think, would argue that actually we, the human species, are only within a couple of 100 years of achieving the necessary technology to move out to the stars and into the galaxy. And we can envisage various propulsion strategies which might do that. Nuclear rockets, antimatter rockets, laser-pushed light sails, and so on. There are various technologies which people have thought of which might get us up to 10 or 20% of the speed of light, and therefore be able to start this process. And you'd think, well, if we can do it, and if there are plenty of others of these civilizations, then maybe they should have done it. Well, let's do try a simple calculation. Given the technology, it's quite easy to show that colonization of the whole galaxy could take place within a relatively short, on the cosmic timescale, at any relatively short time on the cosmic timescale. Suppose, first of all, that an extraterrestrial civilization sends out colonists to a few of the planetary systems nearest to it. When these have established themselves, suppose they in turn send out more colonizing missions, and so on. The number of colonies grows exponentially, and we can calculate the time it would take for them to saturate the galaxy. Let's do that. Well, suppose we reckon that the distance between colonies is 10 light years. We heard this morning that the nearest star is something like 4 light years away. So, let's use that as a figure for the distance between planetary systems. Suppose our spaceship can get up to 1/10 of the speed of light, and that would give a travel time of 100 years. And let's suppose that they take time to consolidate on the planet once they've arrived, say about 400 years. They spend there before they send out more spaceships. Well, our galaxy is something like 100,000 light years across. And so to cover the whole galaxy in 10,000 steps, which is what we would need of 10 light years each, would take about 500 years. And therefore the time, each taking 500 years, the whole time that it would take to colonize the galaxy is something like 5 million years, with these rough figures, obviously, that I've put in. Well, now, the point about that 5 million is that it is tiny in comparison with the age of the Earth, which is 4.5 billion years old, and the age of the galaxy, which is 10 billion years old. Even if we were to increase these figures, say a consolidation time of 4,000 years, that just puts up this figure to 50 million years, which is still only 0.5% of the age of the galaxy. So that means that any technological civilization which had evolved in the 10 billion year history of our galaxy could easily have colonized the whole galaxy. There is no evidence of extraterrestrials near Earth, and no evidence that our planet has ever been colonized. So why? Why not? Why aren't they here? Well, several explanations. Maybe they do destroy themselves before they develop this technology, as I've said. Maybe they don't want to explore the galaxy. They're stay-at-homes. And maybe they do, but they have ethical codes which prevent them from doing it. Well, now let's look at the problem with all of these, really. The problem with all of these is that they only work if the number of extraterrestrial civilizations is very small. If there are millions of technologically advanced civilizations, it would seem highly unlikely that all of them would self-destruct or stay at home or have identical ethical systems, frameworks of non-interference. And that point is perhaps a bit stronger if we realize that the only civilization that we know about ourselves, well, we haven't destroyed ourselves yet. We do seem keen on exploration. We're exploring our own solar system, having explored the whole of the Earth. And we don't seem to have any worry about interfering with other life forms if you look at certainly the animal life on this planet. And in fact, there are actually quite good reasons why ETs might want to colonize other planets. Colonization here has occurred in the past for political or religious reasons. Human beings have always been excited by the quest for knowledge, and a spirit of exploration has flourished. And the same motivation could apply to interstellar colonization. And there's a question too of survival. Our sun is going to burn out after another few billion years. So if we develop the technology in time, then we could go off to some much more healthy stellar environment in plenty of time. And then there's the zoo hypothesis, this idea that they just come and look. But again, that only works if the total number is really small, I think. Out of a large number of independently evolved civilizations, surely some would adopt for colonization. Well, of course, this line of argument doesn't absolutely preclude the existence of extraterrestrials. I'm sorry to disappoint you if my line of argument is sort of not quite what you'd hoped for, but it doesn't preclude it, but it perhaps makes it a bit unlikely. Well, now, calculating the numbers of extraterrestrial civilizations, and this is the famous Drake equation. Frank Drake came up with an equation. Well, again, from contact, do you think there's people on other planets? If it's just us, it seems like an awful waste of space. Well, I think something I've said already is that we need the whole universe, the size it is, for it to be suitable for life to develop anywhere, once even. So it's not an awful waste of space in that sense. Well, suppose we ignore that argument that I gave about colonization. What about the detection of civilizations who stay at home and communicate by radio? Well, the early pioneer, Frank Drake, of the radio SETI program, Search for Extraterrestrial Intelligence program, wrote down an equation, this equation. And I'll just explain briefly what all these numbers are. The answer, N, is the number of detectable civilizations in the galaxy. R is the rate of star formation. Fp is the fraction of stars that have planets. Ne, the number of planets hospitable to life in a stellar system that has planets. Fl, the fraction of hospitable planets where life emerges. Fi, the fraction of those where life evolves into intelligent beings, so life to intelligent life. And Fc, the fraction of planets with intelligent creatures who have the ability to communicate. And L, the length of time such a civilization remains detectable. Well, so this is about communication, them sending out radio signals and how many we're likely to see. And the problem with this equation is that very few of the numbers can be known with any reliability or can be determined experimentally. Now let's just follow, I think, Frank Drake's original argument more or less. Let's put some numbers in, for the sake of argument. Well, some of the astronomical ones are reasonably reliable, and the rate of star formation between 1 and 10 a year is probably quite reliable. The Fp, the fraction of stars that have planets between 1/5 and 1/2, say. The number of planets that are hospitable to life between 1 and 5 in stellar systems that have planets. The fraction of hospitable planets where life emerges, let's put that to 1. The fraction of those where life evolves, put that to 1. Well, if we're saying it's definite that life will develop if it can, and it will develop into intelligent life if it can. I'll come back to this in a moment. Then the fraction of planets with intelligent creatures who have the ability to communicate, well, I suppose between 1/10 and 1/2 of them do. And the answer you get is that the number of civilizations is roughly equal to the length of time that they remain detectable. So Drake and his colleagues argued that communicating civilizations would either be relatively short-lived, or about 1,000 years, or long-lived, hundreds of millions of years. And the upshot is that there would be between 1,000 and 100 million civilizations in the galaxy attempting to communicate. So, that was Drake's line of argument. Now, we can see what the problems are with this, and it is really these numbers. And I think it's particularly FL, the probability of development of the fraction of hospitable planets where life emerges, and FI, the fraction of those where intelligence emerges, which are the difficult ones. And I'm going to just concentrate for a moment on FL, the probability that life develops, if you like, the fraction of hospitable planets on which life emerges. Now, in 1958, Harold Urey and Stanley Miller took a primordial soup of simple chemicals, hydrogen, water, methane, ammonia, and carbon monoxide. This is a famous experiment, and subjected it to electric discharges and ultraviolet radiation, this soup of chemicals. And they found more complicated molecules building up. And it's believed, well, this is just, I'm moving into territory too where I'm not an expert. I have to tell you these biological things. But I think, many still believe that something like that process was responsible for the origin of life on Earth. Now, some quite complicated molecules have been built up through these kinds of experiments, amino acids and so on, even short chains of amino acids. And that looks promising. But when it comes to life, there's a problem of the chicken and egg variety. The basic characteristic of life is self-reproduction, and the code for reproduction is in the DNA molecules. DNA codes for the production of proteins, but on the other hand, DNA needs the proteins to get made in the first place. I think this is a well-known problem. And the translational machinery is so complex and universal and so essential that it's hard to see how it could have come into existence or how life could have existed without it, says pioneering evolutionary biologist John Maynard Smith and his colleague Eoz Zathmari. So this is a difficult problem. And the crucial thing about DNA is the order in which the nucleotides are put on the chain. Unless that order is right, the molecule is biologically useless. So, I'm going to give another calculation. I'm not holding any credence out for this at all. This is, a big sort of health warning on this one. But I think it's probably just as unreliable as the argument that FL is 1. Anyway, suppose that the seed DNA we need to get life going is pretty short, 600 nucleotides. Imagine a large number of 600 nucleotide length strands of nucleic acids forming spontaneously. Let's put a few numbers in. There are something like 2 times 10 to the 44 nitrogen atoms near the surface of the Earth or in its atmosphere. A single 600 nucleotide chain would contain about 2,000 nitrogen atoms. So the maximum number of strands of DNA on Earth is about 10 to the 41. Suppose every strand could split and recombine 30 times a second, then you'd get in 1 year a maximum of 10 to the 50 strands forming. And in 10 billion years, the age of the galaxy, you'd get a maximum of 10 to the 60 strands. The problem with that is that the number of possible arrangements of 4 nucleotides is 4 to the power 600, which is about 10 to the 360. So you get a probability of a particular one of about 1 in 10 to the 300. Now, as I say, big health warning over this, and probably Dennis might well want to query some of these sorts of numbers as a biologist. But and you can do some things even from this calculation to start to bring that number 1 over 10 to the 300 down a bit by saying, well, maybe certain permutations of the DNA molecule are equivalent, and you can get to a much lower number. But anyway, the trouble is we're still very far from getting very far on the road, really, to life. We need lots of genes. We still haven't even got as far as an organism. And of course, the thing is, if you were to put a number like this, though, into Drake's equation, it would swamp all the other numbers, and it would effectively wipe out the possibility of there being any extraterrestrial civilization in our galaxy or even in the universe. Right. Now, of course, there are lots of arguments as to why these numbers might not be right. I mean, evolution doesn't proceed by simultaneous, spontaneous organization, but cumulatively is one argument. But the problem with that is, well, we haven't got off the ground yet. We haven't got the reproductive mechanism in place for evolution to start yet. So, we've got a big problem. I'm wanting to be cautious about, as I say, about these numbers and about perhaps using it in a biological design type of argument. But really what I'm wanting to use it for is to say that the numbers that go into Drake's equation could be really anywhere between 1 and 1 over 10 to the 300. And they certainly could in principle, that particular number could be very tiny. About the search for extraterrestrial intelligence. Well, that has been going on since the 50s with Frank Drake, and I think to have any hope, there have to be lots and lots of civilizations out there. The Drake equation needs to come up with a big answer. You can't allow yourself to side with Michael Hart and others who put the probability of life developing on a planet minute, like in my previous slide. The enormous number of stars. There are other problems though with the program. The enormous number of stars to survey, the wide range of frequencies on which ETs might transmit. It's like looking for a needle in a haystack, but many, many orders of magnitude more difficult. One problem is that we need a window of frequencies which is relatively open, not absorbed by the atmosphere. One particular natural frequency that's been postulated is 1.42 gigahertz, which is frequency characteristic of neutral hydrogen. And maybe aliens might use some natural multiple of such a frequency, 2 times it or pi times it or something like that. Well, that's giving you quite a few possibilities, even if you start from that particular frequency. And whatever frequency they broadcast on even then would be Doppler shifted due to the motion of the alien planet. Now, of course, the technology has advanced dramatically since this program started, and one can analyze many frequencies simultaneously, and the search can be done largely automatically. Project Phoenix was launched in 1992 by Drake's SETI Institute in Mountain View, California, with private funding because NASA had actually pulled out of the program, the original project. But anyway, the project has employed radio telescopes around the world to target thousands of star systems, and those who pursue the research seem to remain eternally optimistic. Frank Drake wrote his book in 1991, believing we were on the threshold of detecting alien signals, but the results so far are still entirely negative. Let me come back to finally then. Yeah, those are some of the things that you need. You need it. Yeah.
On numbers, have these people doing this done a very simple calculation of how long statistically they're likely to have to wait?
Right. Before they detect something.
Because if I was doing a project like that, I'd like to know if in my own lifetime I was
That's
any chance, whatever. Have they done a few studies like that? Please repeat the question.
Yeah, the question is, have these SETI people calculated, if you were the expected time it would take actually to see a signal? I'm not sure that I know the answer to that. I mean, I think they're relying on, on the first calculation, the Drake equation, in which case, if there are plenty of civilizations out there, then and you're surveying, you probably could do a calculation, given what you believe about the Drake equation. But certainly so far, it's the answer at any rate has not been negative. It has been negative. I don't know how long they expect to search. But okay, well, let's think. There have, of course, just been there've been false alarms, and it's very interesting that I was talking to someone earlier today about, and she's been mentioned, Jocelyn Burnell, the discoverer here of pulsars, working with her supervisor Anthony Hewish, who got the Nobel Prize for it, actually. But when Jocelyn Bell first saw these very regular signals, pulses, she thought that these were little green men, and there was some excitement about it, but it turned out that it was now that's very well explained by rotating neutron stars and so on. So, theological reflection. Well, let's think. I think I've shown that the probability of extraterrestrial intelligence in our galaxy, at any rate, is low, and probably in the visible universe it's low too. But I mean, so much is unknown. But the hypothesis, interesting, the hypothesis there are no extraterrestrial civilizations fits all the observations. Scientifically, that is, the hypothesis that's got everything going for it. And there are no observations for which we need to postulate ETs. So on the basis of Occam's razor, we ought to go for the simpler, which is they aren't there. But people are looking. There is a religious motive, as I've said, behind the quest. Well, what difference would it make to religious belief if they were out there? I'm going to concentrate on my own Christian belief, but it's interesting, those other religious traditions might want to reflect about what you think in your own contexts. Cosmologist Paul Davis, working now on astrobiology, thinks it would have far-reaching consequences for religious believers, and especially for Christian belief. But at the same time, he does see the search as part of a religious quest. And there's one line of thought which actually would see this as, in a sense, enhancing rather than undermining religious belief, because it would demonstrate greater creativity on the part of God if he created lots of other intelligent beings around the universe. And perhaps a creative God on this view would be likely to create many. And it might be rather arrogant of us to suppose that we are special or unique. On the other hand, this is perhaps slightly relevant, reminiscent of the best of all possible worlds argument, depending on the quantity of goodness. I think this is a problem for Leibniz's argument, because you can multiply up how good a universe is if you multiply its size or the number of good things or creatures there are in it. Well, I think that's a dicey argument. Bruno, I started with, argued that God's infinitude, omnipotence, and perfection could only be expressed by creating an infinity of worlds. Now, for Christianity, perhaps the most difficult problem that's been perceived is to do with the incarnation, death, and resurrection of Jesus Christ. If there are intelligent creatures besides ourselves who need God's revelation of himself in Christ, and who have sinned and therefore need atonement to be made for their sins, which in Christian belief is through Christ's death on the cross for us, does that imply then that the Son of God would have to be incarnated, die and rise again in many different intelligent life forms? Well, some Christians are perfectly happy about it. John Polkinghorne, for example, thinks that if necessary, God would become a little green Martian and die for little green Martians. Keith Ward is another Christian theologian who's actually looked at other religions as well, but he certainly thinks that an infinite God in principle could take any number of finite forms, though in fact has done so just the once. And many Christian theologians down the ages have taken that view, notably again St. Thomas Aquinas. So if that were the case, then there wouldn't really be a problem. So, on the other hand, there are Christians, and I'm a little bit concerned about this, I think I'd rank myself in these, are not so happy about this. Cambridge theologian Brian Hebblethwaite questions the very possibility of multiple incarnations, since Christ would not be fully human if he also became a little green man on some distant planet as well. Hebblethwaite argues that God the Son is one divine subject, and only one human subject can be the incarnate human form of that divine life. If Jesus is the same person as God the Son, then other incarnations would have to be that person. And as Hebblethwaite says, one individual subject cannot, without contradiction, be thought capable of becoming a series of individuals, or a fortiori as a coexistent community of persons. And that becomes absolutely manifest if you think about the resurrection, when human beings were expecting to see God the Son as one of us, as a human being, and yet we'd be presented, as it were, with a whole multiplicity of individuals who are God the Son. So Hebblethwaite thinks that amounts to a contradiction. And then there's the suffering and death of Christ on the cross in atonement for human sin. We're told in the New Testament that he died once for all. Though, of course, the biblical writers certainly had no concept or idea of multiple incarnations and distant planets with alien life and so on. So there wasn't any particular reason why they should refer to that. On the other hand, the passage in Colossians chapter 1, verses 15 to 20 refers to the cosmic Christ, the Christ who is before all things, in whom all things consist, and who reconciles all things to himself. Romans chapter 8, verses 18 to 25 speaks of the whole creation groaning, awaiting redemption. And it would seem that Christ is both cosmically preeminent and achieves some cosmic redemption on the cross. Well, in principle, as John J. Davis argues, the problem of aliens is no different to the problem of those on earth who are redeemed by Christ, but without having seen him and or heard of him. So they'd include characters in the Old Testament, for example, who we know would be saved, not just from the Israelite fold, but people like Naaman the Syrian, and in other stories, like of Jonah and Job, we get those who are not Jews, who are related to God and are saved and so on. So thinking along these lines leads me to believe that extraterrestrial intelligence, if it exists, even though I regard it as highly improbable, wouldn't be an insuperable problem for Christian faith. However, I'll close with David Wilkinson's thoughts, who was to have given this talk originally in his book on this subject. He talks about the needs expressed through this quest, the need for relationship and meaning and so on, and says that they can actually all be met through the much more accessible and rational route of religious faith, for him, as for me, the Christian faith. And unlike extraterrestrial intelligence, the Christian faith is backed up by a great deal of evidence. It should be overwhelmingly accepted rationally in preference to extraterrestrial intelligence, for which there is no evidence. And Wilkinson concludes, we are not alone in the universe.
Thank you very much for that, Rodney. I'm sure that's stimulated plenty of questions. I'm always amazed, by the way, on the history at how many writers in the 17th century were writing on this issue, including John Wilkins, who was one of the founders of the Royal Society. So they were really thinking about the theology, and they fully expected there to be lots of life on other planets at that time, and didn't seem to have much problem with that. So this is quite an old issue in some ways, which sort of keeps coming around and around.
William Whewell, 19th century.
William Whewell as well, Master of Trinity College here in Cambridge. It's all very interesting. Yes, first question. Yeah.
The implication here Well, first of all, the fact that people have some kind of almost subconscious desire to bring forth, if not in the, more than the imagination, such, and as you say, it's very wide. The very fact that apparently rich people or governments or whoever are funding, against evidence which was the very fact that people are sitting there, presumably looking at screens or God knows what, you think, oh my God, on the basis of this, why not get a life, You see what I mean? So you're saying there's something very odd about this, something very, very strange.
Yes.
So it must be saying something fundamental about the human condition.
Yes.
Which you didn't go on to, as to why. Because there is no logical, on the basis of what you said, and it's going to be really difficult to prove otherwise, there is no logical reason for putting this on our agenda. And you're thinking, well, we've got enough problems around without putting this on the agenda.
Well, yes, I mean, that is a point, isn't it? If we were to contact these, they might be hostile. I mean,
we might argue, or you have argued, that effectively human beings want to put this on the agenda. That seems to be, roughly speaking, what we're saying. So that there's got to be some reason for this. There's got to be some, and it may be well that we should persuade the human race that he should take it off the agenda because he's looking for an escapism for salvation somewhere else. When in fact what they should do is concentrate a bit on what apparently seems to be the only thing we know of. That being so, the fact we might be going to destroy ourselves takes on an even greater significance. So it seems to me, I'd like you to reflect on that. The implication of all that is we better tell the human race that you're rather more special than you thought you were. You just can't go on this way because there isn't anybody else to take over. If you see what I'm trying to get at. It's got quite a fundamental... So why is it this escapism? And why hasn't the human race realised the speciality it has and therefore start acting in that way? Which it doesn't do.
Well, I mean, I think it's probably as much a mystery to me as to you, really, why people have this... I mean, there is this natural urge to explore and so on, which I think is great. And, we all the great explorers of the 19th century, we've sort of covered the earth, and we've found tribes in different obscure parts and so on, and that's great in many ways, and the quest for knowledge and so on. There are some very positive things about all of that, and maybe it's thinking in similar terms, but with such a small prospect of success, and with such vast amounts of money required. And indeed, your point. I mean, we may find that if we come across these other, I mean, if you watch Doctor Who or whatever, they will be hostile. So it might not be all that, sort of healthier thing to do in the end.
If I can just add a point on that, I did hear someone here in Cambridge last week speak from the SETI Institute, and they mentioned there are 160 people working full-time in the SETI Institute, so it's a huge operation. I had no idea myself it was so big. So it's a very, it's a very expensive and quite large operation, and they're just actually building a new astronomical facility for their whole operation. They've been borrowing from other people so far, but they're just building their own facility. So it's just to sort of underline your point, really.
It is a mystery, I think.
Very, very strange.
Yeah.
I mean, does it take
look in
away
this
from people being willing to consider the plight that the world's in?
Well, I think there
Escapism
could be an
is
escapism.
arguably
There could be, yeah.
This is all escapism. Why don't we all get together and think about what we've got? It's so precious. That's the word that comes to my mind. That's almost what the argument is. We are so precious. We are so precious that we should not, almost allow
It's a
people
distraction.
to seek this
I mean,
escapism.
I think one wants to draw a line somewhere where what is a distraction from the right ethical, moral concerns about ourselves, about the planet, about other people, and so on, about global warming. These massive problems we've got, health issues, malaria, is sort of stamping that out. There are all sorts of things like that. At the same time, cosmology is in a sense a useless science. So we do pursue knowledge for its own sake, and that seems worthwhile because it is telling us something about our place in the universe.
There's kind of limit to that idea.
Yeah, well, I think there's it's somewhere the boundary is somewhere between normal cosmology and this kind of totally speculative stuff about extraterrestrials.
Yeah, we can come on this side and then back.
Yeah, but just one comment. I mean, you look at the amount of money that's being spent on science fiction movies. I think that ties in with your argument. You know, we're fascinated with science fiction movies. Let's face it.
Yeah, it's true. I mean, that just adds to.
Okay, so while the mic's over here, we'll have the question on the front, then we'll come back over the side. Yeah.
On another tack, can I ask you any comments on crop circles and what some people would think were very interesting?
I
don't know if people heard
this is about crop circles and sort of funny things of that kind. I must admit, I'm not.
Not every country has crop circles. We have them in England. You better explain.
Well, I don't know.
Oh, you have them in.
Supposed to be alien.
You have them in Poland. Okay, so a few countries. Turkey, does Turkey have crop circles? No. No. Okay, so.
Do you want to explain what a crop circle is?
Well, yes.
Well, use the mic. If you're going to explain, you need the mic. So.
Yes, these are large patterns that appear in crops like wheat in an area around Avebury. They are perhaps 100 meters or more in size. They are beautifully laid out, very precise, interesting geometrical shapes, have been getting more complicated over the last years, and recently have included mathematical patterns of kinds like the Julia set from fractal mathematics. And a lot of people are puzzled as to how it's actually done, and nobody seems to actually report.
So do we invoke aliens? That's the
people
question,
do.
isn't
I mean,
it? They do, yeah, they
speak
do
to local
indeed
people,
invoke
say
aliens because there's no... It's
Other
precisely
people-
an alien of the gaps argument we've got here, yeah.
Exactly.
There are three simple explanations. Can I give them to you? I mean, they may be wrong. They may all be wrong. But I mean, one is, I mean, in some cases there have been people who've done it. Yeah. So hidden cameras, people have done it. So that's one fairly simple explanation. Second, there are certain places where you get, as you all see in fields, you know, sometimes you get wind eddies, especially after storms, that give a particular pattern where the, you know, all the wheat or the corn is actually flattened down. And the third one is fungi, you know, parasites, fungi, things like that. So those may all be wrong. I'm just saying inference to the best explanation is probably where you need to go with that kind of phenomenon. So question from over here. Okay, so should we go Mustafa, and then we're going to front and back. Okay, you're okay. So,
I think that it's a very good name to say aliens of Gapar. Very nice, very nice. So I don't want to say something about extraterrestrials, but I want to underline. I think there's a philosophical wrong argument under this assumption that people, half of the United States people, believe that extraterrestrials visited Earth. I want to say about it. I think that wrong philosophical argument under it is the unidirectional progressive view of history that dominated 19th century. Maybe metaphysical form of Hegel or a materialist form of Comte. It's not different. I think, again, there is a philosophical argument that there is evolution in the history of mankind. So when we take assumption of that kind, philosophical assumption, people have difficulty in understanding when they find something in the history, like, for example, pyramids or acupuncture or something like that, crops, related to crops. They have difficulty in explaining it because their philosophical assumption about the history was a progressive and unilinear. But when they find something like pyramids, so it's a better architecture than 19th century, 18th century. They ask, how can it be? So they don't, in place of renew their philosophical assumption about that unilinear historical view, they are taking that gap, they are making a gap of alien assumption, and they try to put it instead of changing their paradigm of that historical view. I think this is one of the main reasons why more than 50% of the United States people all.
I think I'm not quite following. Are you saying? I mean, I'm not quite sure what the connection between that historical analysis is. Are you saying that that they invoke aliens to explain these artifacts, which are so much more advanced than ours, that are from?
Yes, because when the philosophical assumption of a unilineal history, progressive unilineal evolutionary history.
Yeah.
So how can people who have such a philosophical belief explain pyramids, for example?
Yeah.
There is no way explaining it.
Yeah.
So for this type of historical view, there is a gap.
Yeah.
Because I think they are taking a history of between 16th and 20th century, and they are making analogy to that as if all the mankind's history, humanity, was as such.
Yeah.
So they are making that, I think, a philosophical wrong deduction because of that philosophical view, I think.
Yeah, that's a very interesting point. Thank you. Yeah.
Do you want to use the mic? Yeah.
Okay.
So, yeah.
I think I was trying to just add something. Well, I have a comment and a question. I think aliens are the replacements of the jinns or the golems, or the weird creatures of the Middle Ages. We have a version, there's a creation myth in a theistic faith, and there's a creation myth of the materialistic faith where everything is just random and so on. And I think aliens are just now a replacement of the traditional weird creatures that was explained by God's creation or curse. Now they are some random creature in the other side of the earth. That was just one idea.
Well, that's another interesting thought as well. Yes.
Oh, thank you.
Yes,
and one question. In the first speech, you referred to Fritz Hoyle's explanation of a very improbable nuclear synthesis.
Yes, that's
stellar
right.
nuclear synthesis, and he said a super intellect should have monkeyed with physics and so on. Now that's a good, I think, comment. And I'm not sure why can't we refer to such a reasoning on the biological origin of life. You showed it's so improbable. So then, if it is so improbable, if there's such a complex pattern and so on, so wouldn't someone be justified to again refer to a super intellect which monkeyed with biochemistry this time, but not physics and so on? Of course, this is the intelligent design thing, but I'm just trying to understand why it is not plausible.
I'm not sure that I ought not to pass that one on to Dennis, actually,
because
that's biological one, and we are going to have more about.
We have tomorrow on biology.
Yeah.
Let's pass it on to Simon Conway-Morris and Jeff Schloss. Should we do that? Because they'll probably go into a lot of that more detail.
Okay, thanks.
So why don't we'll have that discussion tomorrow. Yeah. But it's a good point.
Potentially, from what I've said, there is an argument there. I agree. Yeah, but.
Sorry, down here.
Yes.
Yes.
So I'd just like to say that I think there's a tremendous interest in search for terrestrial beings, as was mentioned earlier, and so I can fully support the exploratory interests of people. And I know that there's at least, I think, 3 NASA missions, serious space missions planned, not directly looking for life, but certainly looking for planets which are capable of supporting life, and possibly life as well. But so there's serious money and serious research going into this. Perhaps I could ask, what do you feel about the likelihood of finding carbon-based life form, maybe not in any conscious intelligent being form, but that's already a very significant step for mankind to find carbon-based life form outside our planet. And you could easily start extrapolating that to conscious beings elsewhere. Of course, one has the problem of sheer size and timescales, which were alluded to in the talk. And there are, of course, problems that space is actually a rather hostile environment, and all sorts of catastrophes happen. And whether the catastrophes would have happened in time, even whether it's a question of solar systems burning out, or planets being hit by meteorites or whatever. You've only got to look at the surface of the moon to see how frequently these sort of events can happen, and as you know, it's probable explanation for the loss of the dinosaurs. So there's all sorts of events that can happen in space to wipe out a civilization before it would have had chance to cross the huge distances that would have been involved. So that was really just a comment. But I am interested in your concept, sort of the idea of finding at least primitive life somewhere nearby. And then, of course, the theological part of the argument. I mean, you said, of course, you are indeed a Christian, as am I, actually. But I can imagine that
Excuse
the
me,
realm
I'm
of...
sorry, the sound's being picked up on the background, so I'm sorry if we could just have one person speaking. Sorry, it's just so we have the sound. Sorry, go on. Yeah.
And one thinks about the influence of Christ, for example. And, well, actually, we have even a problem on Earth, in fact, because you have to deal with the people that grew and existed prior to Christ, and the other nations, and there are even some probably right here, but particularly sort of Asian nations, which really didn't come under the influence of Christ in any way that we have done, and we have sort of just the same problem indeed, theologically, translating his experience to their experiences.
Yeah.
So,
I was partly trying to cover that one, and what I was saying about some of the Old Testament characters who are clearly saved, even though they're before Christ even existed. But in terms of more primitive life, of course, my FL calculation is about life. But yeah, I mean, that is so much harder in terms of detection and all the rest of it, because well, you know, if it's just bacteria or something on some distant planet round another star, how will we ever detect that? But even that needs a lot of special conditions to get going. But I have far less doubt about that, or less qualms about it in any kind of sense. No, doesn't really. No.
Just on the origin of life, I mean, I think it would be useful to come back and target some of the questions to Simon Conway-Morris. I think tomorrow that would be interesting, because he has views on that, and especially in the context of extraterrestrial life, he's done quite a bit of writing and thinking in that area. So I think that would be good. And just also to flag up, that, I mean, as a biochemist, I mean, our real problem with the origin of life is n equals 1. We don't have other examples, and therefore making really predictions about probabilities based on n equals 1 is very, very hard. And especially when, of course, we have no idea really how it happened. So calculating probabilities when one doesn't know the mechanism, it's much easier after you know the mechanism, then you can calculate the probability. But since we don't know mechanisms, there is a real black hole there in terms of understanding plausibility. But the RNA world is, of course, the one that most biochemists kind of prefer at the moment for all kinds of reasons. But okay, I think there was... Sorry, you've been having your hand up for a very long time, so I think you should have the next go, and then we'll go back over there. Sorry, yes.
I enjoyed your talk. I'm a little concerned, though, about the argument that you were using to answer Jodie Foster or Carl Sagan, whoever in the movie Contact, about the waste of space. And this talk and the earlier talk, you said we need a universe to be about as big as our visible universe is. It seems like you wouldn't want to say that. On the one hand, you conceded the possibility of George Ellis's small universe, and on the other hand, you just write down Einstein's equations.
So I don't mean we don't mean a small universe in the sense of one that is the mass of one galaxy.
Well, Einstein's equations don't care about the total.
No.
The mass of the universe or its volume. They just care about the density.
Well, that's right. But if one only has the mass of one galaxy, then it will collapse for about a month. After about a month.
Well, it would depend on what volume.
Well,
it is
the
if it's
keeping
got the
other
same
things
density that we have. Unless you're worried that matter is simply going to disperse because there's nothing outside it. But
no. It's starting from a sort of cosmological model in which the initial given mass, as it were, is that of one galaxy, but all the other parameters are the same. I mean, I can show that calculation is actually in Barrow and Tipler, if you want to look that up.
Well, they can't have meant that, because the density is what shows up in Einstein's equations.
Yeah.
And so if you
Yeah.
so maybe they must have been changing something other than the way you're portraying it, as far as I can see.
I'd have to go back and look at the
Maybe I
details
should
of
go
that
and look at it.
calculation, actually. But
Can you
but
sort
there
out
is
that equation maybe
yeah.
afterwards? So I mean, I think it's important, but maybe it's a detail that we
Yeah.
should
Yeah.
clarify later on. If we can move on. Yes, there's a question over there by the window. Yes.
Yeah, I'm just curious about, you've talked about us receiving information at SETI, and I wonder if you could talk about what messages we're sending out. At least I understand that we're also projecting information out to space.
We are, whether we like it or not, in a sense. We just look at all the radio broadcasts and everything that is all part of our human existence. And then we're sending out, with some of these satellites, we're sending out little sort of pictures of a man and a woman, things of that kind. So we're in these probes that are going to nearby stars and what have you.
I was just wondering how that information might be. Like, how would you choose what we would send out?
In fact, aren't they actually putting things into those to do with, say, the structure of DNA or something, which code that? There's sort of pieces of information that that would be common to, at least one would imagine, common scientific information that would be common to other civilizations, and I think we're putting that in some of these spacecraft.
The signals, the guy I mentioned who talked about, who came from the SETI Institute, who I saw last week, was showing a lot of the images that they are actually broadcasting out, and they are highly abstract, symbolic representations of the galaxy, of stars, of people, but in a very abstract kind of way. And we had quite a discussion about whether even intelligent aliens were really going to get the point, actually. But this was a room full of fairly intelligent scientists, and a lot of us didn't get the point, but then we were probably way behind these other guys. But it is a very big issue in the SETI Institute as to what do you broadcast? I mean, at the moment, and they have great internal discussions about this, and what is the kind of communication that might be understood. So they're really into that.
And if I may, did he also talk about, do they have likely areas where they send these, or is it?
Yeah, I think they do. Yes, they do target different parts of the sky. Yeah. Okay, so Subrata, yes, okay.
If we were the only conscious beings who evolved in a minor planet, in one of the so many solar systems, it is indeed a wastage of space. Do you think that argument is really a good argument?
It's not given that this argument from Barrow and Tipler that we need the universe to be the size it is to last for the length of time it does. I think that it's not actually a waste of space, but I need to track that point down in a bit more detail.
And secondly, even human beings, in one species, there are so many evidence that we fail to communicate with other human beings in even day-to-day ordinary life situations.
True.
I wonder how we will be communicating with them, and what kind of language will be they will be understanding, and we will be understanding.
Yes.
Abstract
radio signals,
exactly.
I think is the way the only way it can be. But
we've been broadcasting endless episodes of EastEnders from Britain, for centuries, I think, and maybe that's why they didn't want to make contact. This is the level of culture.
Absolutely.
Well, you keep it. Sorry.
English, that's for sure.
That's for English, but you translate that into your favourite soap opera from your own country. I'm sure I think we'll make this the last question, maybe, or maybe the last two questions, and then we'll move on. Yeah.
Maybe I think more discussion should be done if we are exaggerating bigness of the universe, or maybe time of the universe. Because I think many people make emphasis of the waste of the space or waste of the time. Such, for example, like let's look at a human being. he's throughout his life ejaculating more than billion sperms. Maybe one of them or two of them is becoming a child. And nobody is saying that they are waste.
No, that's true.
It's very important how important is the word, maybe if it's something created.
I mean, this business about waste too would apply to in the biological sphere with you know, the Burgess Shale or something, all these exotic creatures that just came and went and.
Yeah, I think exaggerating.
But this is a waste, or is God just you know, enjoying it?
Especially the theory of relativity, I think, shows that the vastness of the universe, of the long of time, is not so important by showing that time is not absolute and space is not absolute. For example, before maybe people can ask why 10 billion years were wait for creating a bird, or 15 billion years for creating 14 billion years for creating human. Why should we wait?
Well, I think from God's point of view, I mean, he's patient and
relativity in another dimension, 14 billion years cannot be so important.
Yeah.
I think there is too much exaggeration of the vastness of the universe or longness of the time.
Yeah.
That's a good
Thank
point.
you.
I think we're going to have a final question down here, actually, and then I think we should start. Did you have your hand up? Yes.
I think one point is that people who really want to find alien civilizations in other parts of the universe, they forget what is biology and what is evolution, if evolution exists. We shouldn't forget that, for example, if we could be on Earth, and today, for example, discussing, it is partly because the dinosaurs have been swiped off. If they wouldn't have been swiped off, they were so effectively occupying every ecological niche that mammals would have had absolutely no chance. So when we say that other beings are living on other planets, we imagine that they have the same kind of intelligence, the same kind of interest as we have. We Westerners, even in other cultures of human beings and Homo sapiens, they don't have necessarily the same interests. And maybe if there is a higher life anywhere, maybe they could be a kind of crabs or something like that. Why should they be bipedal primates?
Yeah, I think the answer to that really is that there need to be vast numbers, as I was saying earlier on, of other civilizations for there to be a small subset that would be something like us, because as you say, they could be vastly different in lots of ways.